Hey, what's going on, guys? In this video we are going to talk about Quine McCluskey method. Now let's look at an example. Let's say we have a function provided f of w x y comma z that's equal to summation of min terms at these locations 0, 4, 5, 7, 8, 11, 12 and 15. Okay, so this is the function provided. Now according to the location we can write this table w x y z. Let's say remove the commas, w x y z, and I'm going to create a table based on the location. Okay, first location is 0. 0 mean we are looking at this term like 8, 4, 2, 1, right? When we have 4 numbers it goes like this. Now at 0 we have 1, it means this is going to be 0, 0, 0, 0, and then 4 is what? 4 is 0, 1, 0, 0, 0, 1, 0, 0, and 5 is 0, 1, 0, 1, 0, 1, 0, 1, and then 7 is 0, 1, 1, 1, 0, 1, 1, 1, and 8 is 4, actually 8, 1, 0, 0, 0, 1, 0, 0, 0, and then 11 is what? We have 8 and 3, so 1, 0, 1, 1, 1, 0, 1, 1, and then 12 is 8 plus 4, that's 1, 1, 0, 0, 12 is 1, 1, 0, 0, and then 15 is 1, 1, 1, 1, 8, 4 is 12, 12 plus 12, 14, 15. So all of them are going to be 1, 4, 15. So this is 15. Now what I'm going to do, I'm going to group this one based on number of zeros. That's the first thing in Quine McCluskey. So let's go ahead and do that. First we are going to look at 4 zeros. Only one thing is with 4 zeros, that is this one, 0. 0 has 4 zeros. I'm looking at w, x, y, z. Okay. 0 has 4 zeros, and if you look at now the next thing is we have to look at the things that has 3 zeros. 3 zeros, let's look at the terms. 4 has 3 0, so 4 has 3 0, 0, 1, 0, 0, and we have 8 with 3 zeros, 1, 0, 0, 0, and the next thing is, do we have any other thing? We don't have any other thing. The next thing is we have to look at 2 zeros. 2 zeros is 5 has 2 zeros, 5 has 2 zeros, 0, 1, 0, 1, okay. And then do we have any other thing with 2 zeros? We have 12 with 2 zeros, 12 has 2 zeros, that is 1, 1, 0, 0, and we don't have anything else. Now the next thing is we have to look at the values with 1, 0. If you look at this, 7 has 1, 0, 7 has 1, 0, 0, 1, 1, 1. What else we have with 1, 0? We have 11 with 1, 0, 1, 0, 1, 1, and the next thing is we don't have any other 1, 0. The next thing is there's no 0, so only 15 has no 0. So 15 has no 0, 1, 1, 1, 1. So this is how we group this one first. Okay, now the next thing is we have to look at the terms that's only difference by one term. And for that difference, like the changing thing, we put a dash. Okay, let's create another column for that. Okay, once we find out that one, we can put a check mark. It means we don't have to use that one again. Now let's compare this one, 0 and 4. How many locations are changing? Only one location changing, right? So if it's only one location, we can take that one. So we put first the location is 0, 4, because we are comparing 0 and 4, 0, 4, and if you look at this one, for 0 and 4, one thing is changing, only the second location, 0, 1 is changing, I mean the second location is changing to 0 to 1. So this one 0, the changing location we put a dash, and the others just we keep it as it is, 0, 0, 0. Okay, now let's compare 0 and 8. It's also changing by one location. The first location is changing. For that one we put a 0, we put a dash, and the others are remaining the same, so we put 0, Okay, this should be only 4 digits. The first one I had to remove a 0 because we only have 4 numbers, right? Second one was changing location, that why we put dash, and the others are 2. Now we are comparing 0 and 8. For that one, first one is changing, that is dash, and the second, like last 3 are remaining the same, so we put 0 0 0. Okay, now we have get rid of this one, and this one. Check mark mean we don't have to worry about this one anymore. Now we have to look at 4 and 5 and 4 and 12, 8 and 5, 8 and 12. Let's look at 4 and 5. 4 and 5, how many things are changing? We have 0 0 1 1 0 0 0 1. Only the last one is changing, right? So we just have to put a dash for that one. So this is one group. The next one is we are comparing 4 and 5 right now. 4 and 5, first 3 are same, the last one is changing. So first 3 are what? 0 1 0 0 1 0, and the last one is changing, so we put a dash. Now let's look at the 4 and 12. 4 and 12, 0 1 1 1 0 0 0 1. Only the first one is changing, so we put a dash. We are comparing 4 and 12, so we put a dash for the first one, and other 3 just remain the same, 1 0 0. So we have taken care of these 2. Now 8 and 5, 8 5 8 12. 8 5, if we compare this one, 1 0 0 1, so here we have 2 things are changing, so we cannot take this one. It has to be only one thing changing. So since we have 2 locations are changing, we shouldn't consider 8 5. The next thing is we have to look at 8 12. 8 12 1 1 0 1 0 0 0 0. So only the second location is changing. So if we take 8 12, first one remain the same, second one is changing, so we put a dash, and the third and fourth are not changing, so we put 0 0. So this one is done, and we have taken care of this one, and now we have to compare 5 7 5 11, 12 7 12 11. Now let's compare 5 7, 0 0 1 1 0 1 1 1. Only the third location is changing, so we can take this one, 5 7. Other than third location we have 0 1. In the third location we put a dash, and the last one we have 1. Okay, and then 5 11, 0 1 1 0. 2 locations are changing, so we shouldn't consider this one. Now let's look at 12 7. 12 7 1 0 1 1. So we have 2 locations changing. Here we have 0 1 0 1. 2 locations are changing, so we shouldn't consider this one. Then 12 11, 12 11 1 1 1 0 0 1 0 1. Here we have 3 locations changing, so we can't take this one. Okay, so we are done with that one. Now we have to compare 7 15 11 15. From this one you can directly see, for the first one only one thing is changing. 7 15, we have the first one that's changing, so we put a dash for the first one, others are going to be just 1 1 1. And for 11 15, same thing, second location is changing, other than that we have 1 1 1 1. So 11 15 1, and the second location is changing, so we put a dash, and the others 2 are remaining the same. Okay, and this is the derived expression. After we find out comparing this one, we have go to this point, right? Now from this one we have to compare again, but after first of all we compare and got all those things, right? So we put a check mark for that. We did it for everything, so check mark mean it never comes again, so we can just get rid of this part altogether, we don't have to consider this one anymore. Now we only have to look at this one. For this one what we have to do is, here we have to look at 2 things. First we have to see the dash should be matching, and also only one thing should be changing, right? So let's see, do we have any conditions like that? So here we have to have dash has to match. Now let's look at 0 4. Dash has to match 0 4 and 8 12. These are the only 2 things with dash at second location. Okay, so dash is matching, and only one term is changing. First location 0 here 1, others 2 are remaining the same. So we can take this one, 0 4 8 12. For the first one it's changing, so we put a dash. The second one is already dash, and third and fourth are 0 0 0. do we have any other things in the second location dash? We don't have anything. Now the next thing is 0, 8. We have dash in the first one. And do we have any other thing with dash in the first one? We have 412 in the dash in the first one, and we have 715 in the dash in the first one. If you look at the 412, only one thing is changing. 08 has 0 in the second location, but 412 has 1 in the second location. Other than that, other two are equal, right? So we can take this one, because for this one only one thing is changing and the dash is matching. But if you look at 715, it also has dash in the first one, but here we have three things are changing. If you compare with 08, we have 3 zeros, and here we have 3 1. Three things are changing. And if you compare with 412, two things are changing. So we cannot consider 715. So we only have to consider 08 412. But we already done that, because you can see here we have 04812, right? We took this one and this one in the first 04812. We have taken this one, and then we have taken this one, right? When we do that, we got this one. But when you do 08 and 412, we can do that, but it's the same thing, because 04 is already there, 812 is already there, so it's the same thing. So we don't have to do this one, but we have taken care of these. We have to eliminate these things together, all together, right? It's similar to the check mark. Check mark means we have taken care of this part, so we don't have to consider this part again. Now we only have to worry about this. I put red mark. We only have to worry about this one. Let's put a star for this one, and this one, and this one, and this one, and this one. So based on these 5 things, we are going to create the we are going to do the Quine McCluskey method to find out the expression. Okay. Now let's get rid of all these parts, because we need some space. So based on this, what we found out, we are going to create a table. Okay, let's go ahead and create the table. So we are going to have a table something like this. In this table, I'm going to put all the locations. Okay, first we know that we have WXYZ. Let's put it right here. WXYZ, and the given locations in the question, we have the expression, this one, 0 4 5 7 8 11 12 15. Okay, now let's look at the first expression. 0 4 8 12, we have this one, right? We have this one. So 0 4 8 12 is what we have. 0 4 8 12, we have dash dash 0 0. So this is the only thing. Dash dash mean we don't have to worry about this one, but we have to, when we look at this one, we have to think about in terms of W X Y Z. So here we are talking about min terms. Min terms mean we have to get the, we have to make this one into 1. So if it's 0, we have to change this one into 1. It means we have to prime this. First and second location are WX, third and fourth are Y and Z. So we have to prime these two to get 1. So this is going to be what? Y prime, Z prime, or Z bar. Y bar, Z bar. So in that way we will turn this one into 1. So that's going to be the min term expression. Now for this one, the first one. Okay, so this is the first one, and the next one is, here we have, okay, also we have to put the location here. This location is what? 0 4 8 12. 0 for 0 we put an X, 4 we put an X, 8 we put an X, and 12 we put an X. Okay, and the next thing we have to worry about is this 4 5 location. We have 0 1 0 dash. Okay, 4 5 mean, okay, let's not worry about the location for right now. Let's look at this one. 0 1 0, 0 1 0, and then dash. 0 mean we have to put a prime for W prime. Y is 1, I mean X is 1, so we can keep it as it is. Y we had to put a bar because this is 0. So WX Y bar. and the location is 4 and 5, so we put an X for 4 and 5. Now the next thing is we have to look at this 5701-1. Okay, 0 is in the W location, that has to be prime, and then 1 is X, so I keep it as it is, and then Y is dash, so we don't have to worry about Y. Z is already 1, so we put a Z. Okay, so we have this one, and the next thing is 715, that one is dash 111, so that's gonna be just XYZ, and the location is 715, and this location, the previous one is 5 or 7, so we put a X in the 5 and 7, and then the next one we looked at it is 7 and 15, so we put an X at 7 and 15, and the last one is 11 and 15, that is 1-11. 1-11 means WYZ. WYZ. Okay, so W, Y and Z. The location is 11 and 15. 11 and 15. Okay. Now here's the thing. We had to choose a path that will cover most of the thing. And if you look at this one, W and C, if I take this path, it will cover all the vertical part of this one. Like if you have X in anywhere, and if you have vertically some X belong to that, you can take all of this. For this one, we can take this X along with this one, because all the, when you do a path, whatever the X along the path, it's going to take this one. Okay, so the first expression is Y bar Z. Now we have to choose a second one that will cover most of the thing. If you look at this 11 is only occurring at one place, like only occurring for one thing. We don't have any other 11, so we have to consider that one, doing that one second. Okay, so when we do this path, we are covering this one too, because this one is vertically along this X, so that one is going to be our next expression, that's WYZ. Now we have to think about this one. If I take which path, that will cover all of these things. If you take this W bar XZ path, this one is a bar, this one was a bar. Okay, W bar XY XZ bar, you will cover this X along with this one, and also this X along with this one, since they are in vertical. So that one is going to be our last expression, W bar X Y bar. So this is how Quine McCluskey method works. Now you can verify this one using this K-map. Now let's see whether we get the same answer using K-map. Now let's go ahead and do that. Let's get rid of this one. Okay, let's go ahead and draw the K-map. Since we have 4 variables, we are going to have 16 boxes. 1, 2, 3. Okay, this is our K-map, and we are looking at W, X, Y, Z. W, X, Y and Z. Okay, now the next thing is we have to look at the location. This is what 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then let's look at the min terms. At 0 we have a 1, at 4 we have a 1, at 5 we have a 1, at 7 we have a 1, at 8 we have a 1, at 11 we have a 1, at 12 we have a 1, 12 we have a 1, at 15 we have a 1. Okay, now if I take this one, okay, let's also put the location. See this 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay, Now if I take this one, for this one w and x are changing, y and z is not changing, that is 0 0, so we have to put bar for both of them. What about w bar, z bar? So that's first one. And the next one is, we know that in K map 4 is better, like 8 is not 8, it's go like 2 4, okay, 2 power 2 is 4, 2 power, yeah, 2 4 8 16. 16 is better than 8, 8 is better than 4, 4 is better than 2. So here we took 4, we don't have any other possibility of getting 4, right? So the next thing is we have to look at 2. We can take these two, and also we can take these two. Now let's look at these two. For these two, what is changing? Wx are not changing, w is 0, so we put a bar for that one, w bar. X is 1, and then y and z, y is changing, so we cannot take that one. Z is not changing, so we put z, w bar x z. And the next thing is we can take this one. For this one we have w is not changing, so we put w, and then x is changing, and here we have y and z. Y and z, both of them are not changing, so we put wyz. Now if you compare this one with this one, Quine McCluskey method, we have w bar xy, oh, I made a mistake here. This one wyc, w xz. I don't know why do I have this one. This one shouldn't be here. Okay, let's look at this one. The first one is y bar z bar, that one was right, and the second one was w bar. We don't take this one, we didn't take this one because we didn't choose this path. Then third one was w bar xz, probably that one should be here, w bar xz, and the last one is wyz. Here we have w bar xz, wyz, w bar z bar. So this one is matching with this one, right? The same thing. So from this one we can verify the Quine McCluskey method works, right? And that's how we do the Quine McCluskey method. I hope this helps. Thanks for watching.